Circulator Pumps by Freddie and Nick. Okay, so today we'll be learning about circulator pumps, and the circulator pump is the heart of the system, just like you have here, right here. Although smaller like Freddie and less expensive than me on a Saturday night than the heat source, the pump is just as vital to the heating system's performance. Pumps come in a wide variety of designs, sizes, and performance ranges. In a closed-loop, fluid-filled hydronic system, the function of the pump is to circulate the fluid throughout the piping. So basically, if you have, your circulator right here, and then you have the piping, this is just going to start ramping up and flowing that stuff around the system. All right? And in a closed-loop system, the pump is made of cast iron, also called heating circuits. In an open-loop system, the pump material is bronze for potable water circuits. All right? And the type of pump used in hydronic systems is known as a centrifugal pump. Most smaller circulator pumps utilize a permanent split capacitor, also known as a PSC, motor attached to an impeller. As the impeller rotates, fluid within the center opening, called the eye of the impeller, is rapidly accelerated through the passageways formed by the impeller vanes. As the fluid exits the impeller, the mechanical energy converts to a pressure increase. All right? And most impellers are constructed of stainless steel, bronze, or synthetic materials to prevent corrosion. All right. And just to give you an image of some of these impellers, you can see them as shown like right here. Okay. So back to the presentation. A circulator pump does increase pressure at its outlet. A circulator pump does not create a suction at its inlet. All circulators require the entering water to be pushed into the inlet port of the pump by the system pressure upstream. The chamber surrounding the impeller is called the volute. All right? The circulator pumps can be built with different shaped volutes. The volute's shape determines how the pump will be installed on the piping system. And just to show you, right here would be the circular pump, and this here would be the volute. Okay? And inline type circulators have their inlet and discharge ports along a common center line. The inline type of circulator is by far the most common type used in residential and light commercial hydronic systems. Isn't that weird? By modifying the shape of the volute, a design called an end suction pump is created. And no, we're not talking about Josh, because he loves to suck the end of every pump. Alright, end suction pumps create a 90-degree turn in the system pumping. End suction pumps are usually floor mounted and are more common in larger hydronic systems. Alright, and just to give you a little image of an end suction pump, you can see that right here. Alright. And also, I just want to let you guys know a little bit of stuff that my colleague Freddie was looking up. And he says in 2005, NA revenues were $149.5 million, and now in 2011, revenue is increased to $174.3 million. Can you believe it? Can you? All right. Why, you say? I know that you were going to ask that, Neil. Okay. New building construction in the U.S. and Canada. I hope that answered your question. New demand for hydronic heating systems will increase in the demand for circulator pumps. Growth of 2.7% by 2012. All right, so ladies and gentlemen, that was a presentation by Freddie and Nick.